Welcome to this tutorial on sequences in series. So as a motivating example, consider the hiker. Let's say he's walking around on day 1, he goes for 5 miles, day 2 he goes for 7 miles, and so on. Notice that between days he goes further and further, 2 extra miles each day. So the first question is, how far might he go in 25 days? So to start, let's give you some basic definitions and properties. So a sequence is a collection of numbers which could be finite or infinite. Here we have an indexing set and the actual values. So in this case, the starting term is A1 is equal to A. And then for each next term, an arithmetic sequence satisfies that the next term is D times the previous one. So this is a recurrence relationship. The n plus 1th term, the next one, is the previous one plus D. Notice that in this case, if I try to sum all the terms of the series, so this is sum of all the sequence terms. It's notable as a series. You have the total sum is 1/2 the number of terms with the sum of the values between the last one and the first one. Where if you visualize this as half the area of this big rectangle. So you have that overall, the sum of the first n terms is 1/2 n times a1 plus an, but if you use the formula for an, which here you should say that an is equal to a1, the first one, so that's a, plus the number of steps, n minus 1, times the common difference, you get that the total sum is 2a plus n minus 1d, and you multiply that with 1/2 n. In the case of the hiker, the starting term is 5 miles. The common difference is 2 miles. He goes 2 extra miles each day. So on the 25th day, he goes 5 plus 24. Note that the number of steps is 25 minus 1, which is 24, and that's 53 miles. And the total distance is 1/2 25, that's n, times 2 times 5, that's 2 times a, plus, again this is n minus 1, times 2, that's the common difference, for 725 miles total. So as an example 2, consider the following competitive food eater, where he eats 20 hot dogs in the first hour, 10 hot dogs in the second, and so on. You know, this now is the common ratio. So if a competition runs from 9 till 2, so that's for 5 hours, so the number of terms of your sequence is 5. The question is, how many hot dogs will he eat total? And what about if he keeps going? Well, we'll find out. A geometric sequence is like an arithmetic sequence, but instead of adding each time, you multiply by this common ratio. So in our case, the first term is 20, the next is 10, and so on. The common ratio in general could be positive, negative, even 0 or 1. But we'll find out later that special case when the size of r is less than 1. In this case, we'll come to find that the sum of the terms will actually converge. Note that the recurrence relationship description is given here. It says the next one is r times the previous one. So similar to earlier, we talked about how there's a series. This is the sum of the first n terms, and it's just the first term plus the second term plus all the way up to the nth term. Observe that if I multiply both sides by r, I get a similar looking equation, but the first term starts with AR, and the last one is AR to the n. So that if I take the difference, I kill off every term except for the starting one. Oh, sorry, except the ending one and the starting one. All the intermediate terms get cancelled. And that says that r minus 1 Sn is equal to AR and minus a. And in the case where r is not equal to 1, I can divide through to get a formula for the sum of the series. In a particular case, when the size of r is less than 1, then r to the n tends to 0, and so the finite sum tends to what's known as the infinite sum, and that's equal to a over r minus 1. This is something, when we write a plus 8r plus ar squared plus dot dot dot, this is the infinite sum. So in our example, so a1, the first term is 20, the common ratio is 1/2, and so that after 5 hours he's eaten 20 times 1/2 to the 5 minus 1 over 1/2 minus 1, and that comes to sorry, there's a slight error here. It comes to that was right. It comes to 40 times 31 over 32 hot dogs. Maybe they chop them up into little bits. And the convergent value is 40 hot dogs if he eats forever.